Okay, so today's lesson we're going to do the exercise 6E, the vertical resisted motion. I'm going to divide this lesson into two parts, like the previous one, the horizontal motion, horizontal resisted motion, and in part 1 and part 2, just because there are quite a few content we need to talk about it, and it will take a long time to actually go through some of the exercise questions. Okay, so what's the difference between vertical resistor motion comparing to the horizontal resistor motion? So a little revision for the horizontal resistor motion here. If you just look at this object moving towards the right-hand side, the only force that acting on an object, apart from the gravitational force, but remember we don't really talk about the gravities and also the supporting normal reaction force. There's only two forces: the force that goes to apply to the particle or the object. So therefore the particle is moving towards certain direction. There's a force that going from there's a force that going this way here to push the particle or the object moving towards one certain direction. So there's a force that going this way, and there is an opposite force which is also horizontal, that's sort of like against the force that goes to the right or left. Again, depends on the motion. So these are the only two forces that acting on the objects. The force that carrying the object moving towards one direction, and then the opposite force that resists that motion there. Now, for the vertical resistor motion, the things becomes slightly different. We need to break down into two sort of scenarios. And then also we'll have like more than just one resistive force, because this time we need to talk about the gravitational force. So we're going to break down it into the two categories. The first one is when you actually throw the object, upwards. So we have the upward motion here. So for example, if we have the object like this, okay, and I'm going to, throw the object, fired upwards using the initial velocity v0. Okay, so the object's going up like this. All right. So if the object's going up, then we need to think about what is the force that acting on this object right now. So if you think about it now, this time is vertical forces. So therefore we do have it's always going to have a gravitational force that acting downwards. All right, remember this. Is always going to have a gravitational force, and the gravitational force is the acceleration going downwards. So if you think about the gravity is mg that going downwards. All right, it's like F equals to ma, force is equal to ma, but this time acceleration is the g, which is the gravity, acceleration due to the gravity, so therefore the force that goes downwards is mg. So think of it that way. Later we need to change that mg to negative mg because the direction, but now let's just say the gravitational force that going downwards is the mg. Now, if the object is moving up through a medium, like for example air, oil, water, doesn't matter what medium, if the object is moving upwards, there must be a force that going downwards to against that object, right, due to the friction or due to the resistance. So there's another force that's going downwards, all right, and that force is the resistance. Okay, so I'm just going to call this as R, the resistance. But the resistance here, usually for the questions in this exercise, the resistance is going to be the square. It's going to be proportional to the power of the speed. Okay, so it could be just written as the mkv to the power of n. It could be mkv square. It could be mkv. The question will tell you what is the resistance actually equals to. All right, k is the proportionality constant. It's proportional to that value here, so therefore you need to have a k. Again, m is just like the mass, very similar to F equal to ma. All right, so that is the force. So that's the motion, the upward, upward journey here, or the motion moving upwards. Okay, Now, so what we need to do now is to derive a formula for the motion that's moving upwards, right? So the formula would be, if you think about, if the motion is still going up, right? So therefore we still know there is a force that goes up, right? Even though we have resistant forces here, that sort of like against the motion moving downwards. However, the force that goes up must be larger than the force that going downwards. Otherwise, the object is not going to move up, it's going to move down or stay the same. So therefore, if we sort of derive a formula, the F, okay, the resultant force is equal to negative mg, which is the opposite to the force that goes up, plus negative mkv to the power of n, because we have combined the force that goes downwards in the same direction here, so we plus the two together. But instead of writing plus, we have a plus minus there in the middle, so we can just do minus. Alright, so once we have finished that, we can actually change the force equals to ma equals to minus mg minus mkv to the power of n. After we finish this, we can divide both sides by m, so we end up with a equals to, or acceleration is equal to, negative g minus kv to the power of n. So this is the result we're getting. Okay, for majority of the question in this exercise, you kind of need to derive a formula, or if they do give you a formula, that'd be great. If they don't, you need to derive a formula that's very, very similar to this form. And this formula, as you can see, is the acceleration and velocity function. And this is one of the function, the equation of motion that we have, all right? And you need to be able to find a way to change those equation of motions into, different equation of motions. All right, so that's the idea. But okay, so this is the motion that's moving upwards. All right, so let's have a look at what happens if it's moving downwards. All right, I kind of need a bit of space, so I'll just drag this one to that side. Oh, that's pretty cool. All right, now the motion that's moving downwards. So if we have an object right now, but imagine if you're throwing the object like going down. Okay, so throwing the object downwards. So let's just start with here. I'm going to move the object downwards, so the object is going down. Now let's look at what is the force that related to this object. Firstly, we still have a gravitational force that going downwards. The gravity is always going down. Okay, it doesn't matter if you're throwing the object up or down. The gravity is still acting the object downwards. Okay, so think of it this way. All right, now what about a resistant force? So the object is moving downwards. The resistor force is opposite to the force that goes down, which means the resistor force is actually going up. So this time the resistant force is going up. All right, it is still equal to mkv to the power of n. Okay, so there's nothing changed here. So once we know this, then we can again derive a formula. So but this time, have a look at this. This time, these two motions have the same direction. So therefore, when we actually form an equation of motion, we don't put a negative here anymore. We actually put a positive. So that's the only sort of difference at the moment for the motion that's moving downwards. Alright, so F equals to positive mg minus mkv to the power of n. Now another question sometimes student asks is, how come it's mg minus the mkv to the power of n instead of these two switch them around? Again, remember the motion is moving downwards, okay? So the object is still moving downwards, which means the resultant force is larger going downwards. So that means mg, or the gravitational force, must be greater than the resistant force. If you do the other way around, then you end up with a negative sort of force, which means the object is not going downwards, it's actually going upwards if the resistor force is greater than the gravitational force. Okay, all right. So once this is done, then we can actually change the the force equals to ma, which is equal to positive mg minus mkv to the power of n, and acceleration is equal to g minus kv to the power of n. Alright, so very similar to the previous equation, right? Almost identical to each other. As you can see, the only difference is probably just one is negative g, the other one is positive g. Apart from the direction, when you look at a question, you just have to be extra careful, read the question, whether the particle is moving up or down. Because otherwise, if you miss one little negative, you basically the entire question is not going to be right. Okay, all right. Another thing that you need to know is the starting position and also for the initial condition. So usually in most most cases, it's best to put the origin as the initial position. Okay, with upward motion as a positive direction as well. All right. So for example, with upward motion, we treat the positive direction as going up, and also initial condition is when the object is initial here. Okay, so for example, when t is equal to 0, y or the vertical displacement is equal to 0, then you can have an initial velocity of certain things. Okay, so v could be equals to v0 here. All right, now with the downward motion, it's just again we sort of best practice is put the origin as the initial position with the downward force is positive direction. So this is the positive direction, and then for the initial condition is we actually put it here. So t is equal to 0, y is equal to, well, in this case here it's a bit tricky. You can treat y is equal to a certain distance above the ground. It depends on whether you're treating this ground level as your initial or if you're treating the starting point as your initial. It's up to you, to be honest. I sort of prefer to have y equal to 0 as when it's on the sea level or the ground. For example, y equals 0 here, so we can have like y equals to y1, depends on what is the distance here equals to. But again, it doesn't matter what you're doing. You can treat y is equal to y0, which means the initial position you're making this point as your level ground. So the later, you just make sure y is equal to negative number for any points that's after the ground. That's all. Okay. Otherwise, everything else should be okay. All right. So v is equal to v0 as well. Okay. If the particle is moving downwards, you have an initial velocity. It could be something else. All right, so this is just the concept here. All right, now to sort of give you a more idea about how do we change an equation, of motion from the acceleration of velocity to other equation of motions, I will just make another summary for you to understand what's going on here. So we've got an equation of motion, the acceleration and the velocity equation, which is in terms of like negative g minus k v to the power of n, or g minus k v to the power of n. All right, it doesn't matter which one you are using. Okay, so the first things we need to understand here is if we want to change this equation of motion from AV equation into, let's just say, the VT equation. All right, so if I want to change that into velocity and time equation, what is the method that you need to do? Okay, so if you want to do that, the method is you're going to change the acceleration. So what I'm going to do here is to show you the process. So if you want to change into velocity and time equation, you need to change the acceleration into dv over dt. Okay, this is the critical one. Change that. Right, the reason why you change into dv over dt is you have v and you have t. All right, you have v and t. Great, that's what you need. And then you do the reciprocal so you can integrate. Okay, so that's what you need to do. You find a reciprocal, all right, and you use your use your integration skills to actually integrate it, so you get the t equation in terms of v, of course. All right, and then it depends on the question. You can make a v as a subject if you want to. Then there will be later algebra calculation. So I'm just putting dot dot like this. Okay, so this is what you do. All right, if you want to put it into VT equation. Now, what happens if I don't want a VT equation? What happens if the question tells you, oh, I need Vx equation? All right, so velocity and displacement, not velocity in time, but velocity and displacement. So in that case, what you need to do is slightly different process. Okay, so instead of letting a equals to dv over dt here, we're going to let a equals to v dv over dx. Okay, so I hope by now you're very familiarized with what the process. All right, so once this is done, okay, so using different color, v dv over dx. Now, again, the reason is very clear. You've got x, you got v and x, and a v here, so that's vx equation that you need. But after this, you just have to divide both sides by v, okay? So that gives you plus minus g minus kvn over v, and then you do the reciprocal. Then you, after that, you just follow the same process of integration. Okay, so I just feel like, sometimes the student a bit confused about, okay, I have this function here, that's an AV function, what should I do? What should I do to change that into VT function? What should I do to change that into VX function? And after we change into VT function, how can I change into XT function, AT function? All sorts of questions related to, they just unable to change from one function to other functions. So I hope this little summary can help you to actually understand how do you change it. All right, now after this, we just have to go to look at 2 examples first. I actually put 4 examples: question 2, question 6, question 7, and question 8. But let's just do 2 examples at a time. And again, feel free to just pause it in time if you need time to write anything down, or if you don't understand anything, and go back to to the points. If you don't understand a certain concept, you just want to listen to the recording one more time. Okay, so question 2. All right, I'll give you time to have a look at question 2 first. All right, an object of mass 0.5 kilograms is projected. Okay, that's the mass. So what I'll do is label. Very important. This is mass. Is projected upwards. All right, keywords here. You guys have done an assignment. All right, you know how important the keywords are. All right, so look at the keywords. This is going up. With the velocity, okay, looks like that's the initial velocity, so I'll write down v0 is equal to 40. So this is the way I read question. I actually annotated the question, so you don't have to read the question again. All right, experience a resistor force, all right, in newtons of that magnitude, okay? So that is the resistant force, which is the R, where v is the velocity of the object at time t. Okay, assuming that g is equal to 10 meter per second square. They're pretty kind, making 10 instead of 9.8, so make sure it's okay. So we've got everything we need. All right, so now the first question asks us to show that acceleration is equal to that function there. So that's a pretty simple question. All right, so question A, let's draw a diagram. It's going upwards. All right, so there's a force that's going upwards, but there's a resistance and a gravitational force that goes downwards. All right, so this is very similar to the summary we just did before. Now you just need to write down everything you have, right? M is equal to 0.5. Initial velocity is 40 meter per second. What else? We have the resistant force is equal to 0.2 V. And we've got G is equal to 10 meter per second square. All right, so once you have this information, all right, I'm just going to remove the question. So I've covered the question. So you don't need to look at the question anymore. Okay, you don't need to read the question multiple times because you don't get anything after you're reading the question multiple times. These are the only things you need, all right, to solve all the questions now. All right, so firstly, equation of motion. The force is equal to negative mg minus r. All right, so ma is equal to minus mg minus the resistant force, which is 0.2 v. All right, divide everything by m. That gives you minus g minus 0.2 v over m. Okay, so 0.2 v over m. All right, and then all we have to do now is substitute m equal to 0.5 inside. So acceleration is negative g minus 0.2 v over 0.5, which at the end, after you simplify it, that's minus 5 g minus 2v over 5. Okay. Oh, minus 50. Why is minus 50 here? Did I make a mistake? Yes, no, I didn't. I need to substitute the g equals to 10 inside, so acceleration is equal to 10. So minus 50 minus 2v over 5. All right, so here we go. That's acceleration. Okay, so that's the acceleration here. All right, so pretty simple. I hope you understand this. It's not that hard. All right, you can actually do the question. Now the next one here. Again, I'm just going to cover everything. You don't need to read the question again. Just trust me. You don't need to read the question again. A diagram with all the information here is enough. Do not waste your time. Show the object takes this amount of seconds to reach the maximum height. Okay, now a couple of things that you need to understand here. Seconds, that's the time. Maximum height, okay, is when the velocity equals to 0. If you think about it, you're throwing the object up, right? So the object is decreasing speed until the velocity reaches 0. So that gives you the maximum height. So from this information here, we need the velocity, we need the time. So velocity time function, okay? All right, so now go back to A. This is acceleration and velocity. So this is the pathway. We need velocity and time. All right, to get what I mean, all right, all you need to do is be able to identify what the question is asking and what you need to achieve, okay? So question B. We'll start with here. A is equal to minus 50 minus 2v over g. We need to get the vt function, okay? The vt function. Or the tv function, doesn't matter which one, okay? Because at the end we get the velocity equal to 0 to find the time. Looks like the tv function is even better. All right, so the step here is we need to change the a into dv over dt. We need to reciprocal both function here, so both sides. Oh, y is equal to g. Sorry, it should be a 5 here. So that should be a 5. All right, so 5 over minus 15 minus 2v. All right, so that's dv over dt. I can now integrate dv. All right, so I hope integration shouldn't be a really hard question for anyone to do. I need to have a 2 on the top, however I have a 5. So what I need to have a negative 2, right? But I have a negative 5. So you move the 5 over outside, and then you have a 2 here, and then have a half outside. Here we go. And that's how you get negative 2. So once you have this, then you can just do integration, and that's a logarithm integration. And plus c. All right, okay, so now the tricky part is we need to find the c. Finding the c is not hard at all, okay? Finding the c is actually pretty easy. So what we need to do is we go back to what we left before. We need to use our initial condition, that one. Initially the velocity is equal to 40. Alright, so initially velocity equal to 40 means when t equal to 0, velocity is equal to 40. Alright, so substitute the value inside, we should be able to find what's c equal to. Alright, let's do that. So 0 is equal to 5 over 2 ln. Let's put a 40 inside. That is a pretty large number. If you put a 40 inside, negative 100 and let's see, negative 130. Yes, I know how to do the question. I should. Okay, and negative 50 minus 80 is negative 130 plus c. All right, so you've got our absolute value here, so we can remove the absolute value. C is equal to minus 5 over 2 ln 130. All right. Hope this is correct. All right, so once this is done, I can actually substitute the c back into here. All right, and how about I'm just going to copy this one to the next page. All right, so we have t equals to 5 over 2 ln negative 15 minus 2v, okay, minus 5 over 2 ln 130, oh, not 135, 130. All right, then we need to let v equal to 0. We need to find the time, so we let v equal to 0. So the time is equal to 5 over 2 ln negative 50 minus 5 over 2 ln 130. So at the end, that becomes 5 over 2 ln 50 over 130. Okay. Right, so 50 over 130, let's see what's the answer here equals to. 50 over 130, that is 5 over 2 ln 5 over 13. Okay, that is the time. I hope that's the time. That is the right one. Let's see. Oh, it's not. It's 13 over 5 instead of 5 over 13. So I made some mistake somewhere. Oh, okay, let's see, where did I make mistake? That's pretty interesting. Where did I make a mistake here? It must be somewhere I made a mistake for the integration, I guess. If we take the negative outside, that becomes a plus and plus. Okay, don't like this. Okay, alright, how about just do something different? Okay, so it must be just a problem with a negative in the front, because I miss a negative. If I do have a negative in the front, like for example a negative here, then everything else becomes okay. You can change the negative to what's inside and do the reciprocal. So that's the problem. That's where I'm looking for negative. Where did I make a mistake was negative. Alright, so imagine if I just take negative outside, that becomes negative 5 over 50 plus 2v, okay, dv. Oh, okay, I know why. Yes. Alright. Okay, a good demonstration that, if you make a silly mistake, I'm just going to highlight my mistake here. That was a 5 here, now it becomes a negative 5. I actually, introduce a negative number which is not necessary, and that is the mistake. So yeah, it should be a positive. So that should be a positive, which means that should be a negative there if I need a negative again. Alright, so that now everything else works perfectly. Okay, so that's negative. So good demonstration, like if you made a silly mistake somewhere, then it's just really hard, alright, to get to the final answers there. So that's a positive, alright. But everybody do make, silly mistakes. So you just need to find a, maybe like in exams, alright, if you do know that you always make silly mistake, but you need to have a way to help you to check where you made a mistake. Like, like what I did is, the answer is different. It's my one is 5 over 13, so I was like thinking about, okay, I missed a negative, or somehow there was just a little problem with positive and negative there. All right, so if that's a plus, that will be, let's see, we need to have a negative in the front. Yep, so that will be a negative. All right, and then that will be a negative here. So C will be a positive. So that would be a negative, that would be a plus, that's negative, that's plus. So now everything becomes better. All right, so that's negative, negative. All right, so at the end, that becomes 5 over 2 ln 13 over 5. Okay, so that is question B. All right, next one. Find the maximum height, or show the maximum height reaches is this amount of meters. All right, now this is interesting. We've got maximum height v equal to 0. We know that. This is in terms of meters, which means we need the x, all right, the x values. So now the second part, or question C, the third part requires us to actually find Vx equation, which is here, the Vx equation. So we need to use this method here to find the Vx equation and to show. All right, let's start. So let's just using this equation and also the initial condition to start. All right, so I'm just going to do it again. Next page. All right, so question C. We know that acceleration is equal to minus 50 minus, minus 2v over 5. Minus 2v over 5. All right, so we need to change that into the Vx equation. So we do v dv over dx. Alright, so let's hope I'm not going to make any mistake here. Alright, continue the process. v dv over dx is minus 50 minus 2v over 5. So dv over dx, you divide both sides by v, so that's this. All right, after you finish that, then you need to do the reciprocal. That gives you dx over dv is equal to. Oh, by the way, you can, instead of using x, you can actually use y. Okay, so x is sort of like representing the horizontal displacement, since we're talking about a vertical here. So it's better to use y, otherwise sometimes people get a bit confused. So you can do dv over dy, dv over dy, and then the dy over dv is 5v over minus 50 minus 2v. Alright, so once this is done, then we need to be able to integrate it. Now the integration here is a bit tricky to do, so y is equal to minus, I'm going to take the minus out, 5v over 50 plus 2v dv. Alright, okay, so how do we integrate that? So we've got a v here, we've got 2v there. You can use two methods. You can either use a long division to do it, or you can move the 5 outside, and you can attach to the 2, then you can plus 50, then you can minus 50. You can go through that algebra manipulation to do that as well. It's up to you, okay? It's up to you which way you like to use. I would just use the algebra manipulation like this. Alright. 2v half plus 50 minus 50 over 2v plus 50 dv. That's why people say mechanics questions are hard, because not only you need to be able to do the the motion type, you also need to know how to integrate. Alright, so that becomes 1 minus 50 over 2v plus 50 dv. Okay, here we go. Alright, that should work. Now I just need to integrate. So y is equal to minus 5 over 2. So to integrate, that's v minus, this one is 50 over 2 ln 2v plus 50. Alright, plus c. Okay, I hope this is right this time. Really hope there's no issues. Alright, now, next one is when y equal to 0, the initial starting position, the velocity is equal to, back to the previous one, the velocity is equal to 40. Alright, so when y is equal to 0, velocity equal to 40, I just need to find out what c equals to. Alright, this is pretty hard to do. 40 minus, that's just 25, ln 80 plus 50, which is 130, so 130 again, plus c. Alright, so c is equal to 5 over 2 brackets 40 minus 25 ln 130. Alright, so this is what c is equal to, alright, which at the end that is equal to 100 minus 5 times by 25, 125 over 2 ln 130. That's just a c. Can you imagine this is just a c? Okay. I'll probably just break the video into right now I think about it. Alright, okay. Yep, so that's just a c. Now I need to put a c back. So y is equal to minus 5 over 2 v minus 50 over 2 ln absolute 2v plus 50 plus c. Now this is just a c. Okay, alright. The question asks you to find the actual maximum height. So maximum height is when v equal to 0. So we'll let v equal to 0. We need to find out what is the height this time. Now remember, this time the height is the maximum height. Alright, this is the maximum height. So y is equal to minus 5 over 2, 0 minus 25 ln 2v plus 50 plus 100 minus 125 over 2 ln 130. So y is equal to, alright, let's keep going, 125 25 over 2 ln 2v plus 50 plus 100 minus 125 over 2 ln 130. Alright, okay. Did I make a mistake? Yes, I did, again. Alright, velocity is equal to 0. So I need to not just substitute into here, but I also need to substitute into there. So velocity is actually equal to 0, so nothing there. Okay, that looks much better. 125 over 2 ln 50 over 130 plus 100. Alright, so final answer. 100 plus 125 over 2 ln 5 over 13. That is the final answer. Alright, let's just go back and check. Okay, that is the final answer here. 100 plus 125 over 2 ln 5 over 13. Yep, that is the answer there. Okay, all right. Yeah, that's it's a really good question here. Question 2, a very good question. I actually picked this question just randomly, but this question I perfectly sort of show you what's going on from AV functions here. You need to change into VT function, and you need to change to VX function. It's a perfect example, really good example here. All right, so I'll stop the lesson to that. For the moment, this is just a part 1, and I will record part 2 later. Thanks for watching.